First question, how's the sound? Raise your hand if you cannot hear me. Y'all got that, that's good. I'm Rob Peglar from XioTech. I don't want to spend a lot of time on my background, Phil did. I've been doing this for a while, and I won't reveal my age during the presentation, but I'm 35 in hexadecimal, so y'all can figure that out. Did want to talk about some real, this is an hour worth of material that I'm going to cram into about 25 minutes, so bear with me. I did this at the state of Florida government IT show a couple of weeks ago, and talking to the state CIO of Florida. State budgets are an interesting thing these days, let me tell you what. Y'all in the private sector have your own challenges, but state governments are interesting. So I did this in 60 minutes. We'll cram it down to 25 and then leave some time for Q&A. How's that? Very good. Now, first things first, I am from St. Louis, or as my wife says correctly, I live on airplanes. And I must tell you, I am neutral on the subject of tigers versus gamecocks. So are we okay with that? Totally neutral. The only tigers I care about are University of Missouri, where my daughter goes to med school. So those tigers are okay. All right, cloud computing. Who's heard of that? What does it mean? Well, the good news is it's a cloud. You can kind of define it any way you like, right? But here's 3 points about cloud compute that are really, really important. Number one, this is a great word, elasticity. All right, if you majored in economics, you kind of know what that is, but elasticity is very important for cloud because if I'm going to use a cloud computer, cloud storage platform, I want to spin up instances, right? I want to create new machines very, very quickly, and I want to take them away just as quickly as well. I mean, the analogy might be plugging an appliance into the wall and then removing the plug. I have power, then I don't have power. That's really important for cloud. This is one thing that differentiates it from managed hosting. Right? Managed hosting is typically not elastic. You can bring up an instance and it lasts a long time, years perhaps. Cloud storage, cloud compute might last for 15 seconds, just enough time to do the work. So workloads, remember the ability to spin up and spin down, very important, and the on-demand aspect, that's aspect number 2. It has to be elastic and it has to be on demand, right? I mean, we're all impatient people now, right? As we get older, I want it now, not 2 minutes from now, I want it now. Because I've got a 20-second compute job that I need to run and I need the results, and I don't have room or the dollars to do it on my own equipment. So demand is important, and then the third thing is delivery. And this is one of the questions that a lot of people don't understand about cloud. How do you deliver data into a cloud? Back and forth, right? And this is not, well, I'll take my box of tapes and ship it to the cloud provider. That's not delivery on demand, right? So that's a very important thing. So you either do it via a proprietary method, like Amazon S3. Who's used that? Yeah, that's a proprietary API. Works, but you're also, if you use that, that's the only cloud you can talk to, right? And there are hundreds of them out there. So using an open source or a public API, and we're going to talk about those, is much better because you might want to move your workload from Cloud 1 to Cloud 2. Maybe Cloud 2 gives you better pricing. How do you move your data? How do you move your compute tasks? So that's very important. And for any serious cloud provider, they must have an enforceable SLA. If you go to Amazon's website and read about their service, it's a wonderful service, works well. Their SLA has no teeth. You are computing on a best effort basis. This is one reason why a lot of private data centers don't want to do cloud. Because if the cloud goes down, they're stuck. They're done, right? No recourse. So SLAs are really important. That's what that means. So what are the great challenges? Well, we all know there are 2 great motivators of human behavior. Fear and greed. Right? And so it is with cloud compute. Why do people move the cloud or not? Well, some are afraid of it. Right? Well, it's kind of nebulous. It's a cloud after all. What does it really do for me? Right? How do my users relate to it? We had some great questions turned in before. And then if you talk to other very well-entrenched IT folks who might have worked in a data center for years and years, they're just outright scared of it. It's job insecurity. They think they're going to lose their job. And the answer is no, you're actually not. right? Build a private cloud, and then you become the master of that cloud. It's an even better way to sharpen your skill set. But the biggest impediment to cloud by far, and you can see that, is the movement of data in and out of clouds. Right? Now, fortunately, what Phil said, the SNIA, Storage Network Industry Association, which I'm on the board of, we are defining an open standard on how to move data into a cloud service and, more importantly, retrieve that data, right? And move it from one cloud to another. This is absolutely key, because I have news for you. It is all about the data. Compute is all about the data. There's no question about it. When I was taught, you know, back when we had, you know, bearskins and stone knives and computer science, right? Punch cards, anybody?
Yes.
Oh, yeah. Oh, yeah. You carry them under your arm. Do not drop the box. I wrote a compiler in PL1, 2,000 punch cards. Do not drop the box. Yeah, very important. We'll talk about mainframes in a little bit. But the whole idea is we're so data-centric now. I mean, IDC just did a study. Today, you got one of these? iPhone or equivalent? Oh, sure, all of you do. Of course. If you don't have one of these, you're lying to me, right? Multiple? Yeah, more, flash memory, anybody? Stick, USB stick, multiple? You ever lose one? Oh. I have a friend that worked at Bank of America. Not in Charlotte, but in St. Louis, where I live, right? He had a USB stick, 2 gig. He left it in a taxi cab. You know what was on it? Loan applications in the clear. Name, address, social security number, employment history, references, credit scores. Ouch. Message number 1, please encrypt your storage. Okay, one of the questions I got was, well, how do we secure data in and out of the cloud? It's like, please encrypt your storage. Don't send data to the cloud in the clear, please. Because if you do, you're asking for it. So encrypt your storage. And there's also, this is not a lecture about encryption, there's all sorts of methods to do that. That is by far the easiest and simplest way to secure your data in and out of a cloud. You should be doing that in your own data center, by the way, even on private equipment. So these are some of the things that people worry about with cloud. Security, vulnerability, right? Did you know that there are now papers written by the academics in the field of how to do a virtual machine takeover? I can go to Amazon and set up my virtual machine. I can take yours over, right? If you don't secure it. It's true. Virtual machine takeover. It's an interesting thing. So how about cloud storage? Right? IDC says in this year and into next year, 2011, the amount of data we have personally in our houses on things like this will exceed, for the very first time, the amount of data in enterprises. It's absolutely true. Right? How many terabytes you got in your house? 3? 5? Anybody else? Home NAS? Home SAN? Gotta have home SAN, man. So I have 12 terabytes of data. Not that kind of data. Don't go there. I don't do that stuff. But I got a lot of data. Right? Because you have to back up your data, right? Got to have backups and replicate in your house, right? You're going to get there. Trust me. Right? Because terabytes of data in the house are not uncommon these days. Right? This is why, even though there are exabytes of data out in enterprises, personal storage will eclipse that and the lines diverge. Digital camera? Oh yeah. Right? Lots and lots of pixels, HD. Sure. Video. Absolutely right. HD video takes 4 times the storage of SD video, not twice, 4 times. It's a great thing. So cloud storage. What is it? Well, the SNIA has defined it. It's this delivery of virtualized storage on demand. Right? So it's got all 3 parts. It's elastic, there's a delivery method, and it's virtualized. It's on demand. Right? That's what cloud storage is. You may be using cloud storage today and you really don't even know it. Right? In fact, Phil was talking about iPad. I'm going to have my lovely assistant Tim here pass this around. And how do you monitor cloud storage? Well, there's an app for that. Right? You ever heard that one? There is an app for that. Right now, you know, the slight vendor pitch, we make storage elements. I'm not going to talk too much about it, but we actually participate in the cloud storage market. And the question is, well, if I've got data on a cloud, how do I manage it? right? I know how to manage kind of my own disk drive on my laptop, kind of. I know how to manage storage arrays in my data center, kind of. Well, how about the storage in the cloud? Did you mess it up already?
Don't push that button.
You did mess it up already,
It's the one right there by your thumb. Don't push it.
There we go. Try that for size.
There you go.
I'm going to get a new assistant here pretty soon. All right. So there are three aspects to it. But compare it to an electricity grid. You plug in and you receive power. Now, how many of you have traveled internationally? I sure have. Lots of you, yeah. Now, there are different plugs for different countries, right? You kind of have to know this going in. And if you've ever traveled out there and you have the wrong plug or the wrong adapter, it's like, oh man, now I got to go buy the 3, 4, 5 prong thing and so I can plug my hairdryer into the wall, right? Well, that's true, but you know that you're going to get power. If you have the right plug, you're going to get power. The power plant manages the grid, not you. Right? That's what some people don't get about cloud. You don't have to manage the grid. The provider does. Right? All you have is your data, sending it back and forth. So you know what plug you can use. You can buy them anywhere. This is the analogy to open APIs. Right? With an open API, you know what you're going to get. With a closed API, you got some funky plug that only that guy uses. It's not a good model. This I love some of the slides in here. This is a good one. What's cloud-ready storage? So question number 2, you think the element on the left or the element on the right is cloud-ready? Don't you love this? I use this. Anybody ever use one of these? Yes. What is that? That's a disk drive. It was the size of a small washing machine. This is a CDC Model 844. I use these because I work for control data. And it was open air, right? You put the handle on, you screw it down, you lift the disk platters out, carry it under your arm down the hall, put it on a different disk drive. Removable storage. Circa 1972. That'll give you a clue, right? Guess how much data is on there? Close. 600 whopping megabytes. Megabytes. Now, I don't know about you, I get about 600 megabytes worth of email every single day. I would have filled $30,000 for that, by the way. You talk about dollars per terabyte now? $30,000 per 600 megabytes. You figure it out. Well, that's not quite cloud ready, right? We had to manage that, and there was a fine art to doing that, right? A lot of storage administrators did that for a living. Well, what we want to get to is elements. How many of you are on blade servers or know what they are in your infrastructure? Blade servers. Yeah, it's pretty common these days, right? Because blade servers scale. They're all the same. If you want to scale your compute power, you buy another blade and plug it into the enclosure. And you manage it just like all the other blades are managed. Well, we should be doing that for storage, too. I want a blade storage. I want an element that I can plug in, recognize it, get my space, and more importantly, get my IOs, and it's all the same as all the other elements. It makes things very, very simple. I know lots and lots of data centers that complain, well, we've got 5 different vendors on the floor. It's really hard to manage, and I have to virtualize them and all this stuff. I get it, right? I get it. Let's make things simpler, right? What did Einstein say about simple? You all know that one, right? Everything in life should be as simple as possible, but no simpler. Right? So how do you get to cloud storage? This is the geek part of the presentation. Right? There are 50,000 foot parts. There are 1.5 inch parts. Right, Pam? Very good. So how do you get to it? Well, there's 3 ways. File and print, right? Normal, unstructured data. Word documents, PDFs, things that humans can interpret, right? Very simple. There's a defined method to do that. It's very, very simple, and it's an open standard, right? So if you say, well, how do I move my Word doc into a cloud? This is an answer for you. And then the other one is CRUD. I just love that acronym, right? Objects. In database terms, they call them blobs, right? Binary large object, blobs of data. Could be any size, right? And there's a method to do that. The one thing that cloud storage doesn't do well today, and you should know this, is relational database I/O. Oracle, SQL Server, Informix, DB2, all the classic databases. Really hard, at least for now, to train a database to use cloud storage effectively. Let's put it that way. Number one, you don't want to suffer the latency back and forth to the cloud with a database. If you expect, 5 millisecond response time, ain't going to get it. And that's very important for databases. So that's not defined yet. It will be over time. Because believe me, there's an interesting thing about data transfer, right? And this is a storage guy telling you this. The best I/O is no I/O. The best data transfer is no transfer because it takes 0 time. Right? Y'all try to transfer a petabyte over a T1 line? Now, in my lifetime, that probably won't finish. Right? You guys can do the math on that. That's the problem. We have lots and lots of data, and typically the communication infrastructure isn't quite up there yet for for non-trivial data sets, let's put it that way. Right? Now, if you're blessed to have an OC48 or 2 lying around, cool. Right? But most companies I know don't do that. Plus, have you priced one of those recently? From your favorite telco, OC48, get your checkbook out. Hundreds of thousands of dollars per month. Right? This is what it all looks like. There will not be a quiz. But that's what it all looks like. I've got cloud providers, right? The management interface, this little piece called the CDMI over there, that's what the SNIA is working on. It's public domain. And if you are thinking about using a cloud provider, either from your own business or perhaps setting up your own private cloud, so your internal customers, employees, staff, contractors can use cloud services, you want to go get that document, right? Because that's how you not only manage storage in a cloud, but also provision and, more importantly, deprovision, right? I want a volume for a little while, and then I don't need it anymore. Cool. I want to deprovision it. So all the data services and storage services like replication, backup, snapshot. Who's heard of that term, right? Snapshot of data, right? Those are all defined in the spec. How do I take a snapshot of a cloud volume? Actually, the answer is in there. That's an interesting thing. All right, private cloud. This is what most data centers I talk to are first interested in, is private cloud. I've got a data center. It's not set up to deliver elastic, on-demand services on delivery. It's not quite set up for that. It's close, right? Remember the batch job? Raise your hand. Batch jobs, anybody? Yeah. We're coming back to batch jobs. Did you know that? Because it's a defined set of tasks I want to give up to the cloud compute engine and then get the results. This is a batch job by any other name. There are no great ideas in IT. There are only old ideas made new. It's true. Virtualization. Nice thing, isn't it? Virtual machines. They're all over the place now. Right? Guess who did virtualization first? You mainframers, stand up. Right? 1967. 360 Model 67, anybody? Oh yeah, virtual machines. This is a good idea made new. Absolutely right. So private cloud. When you put together a private cloud, you want to be as efficient as possible. Right? Because why are people virtualizing servers today? Well, who's done virtual servers? VMware, Hyper-V, Citrix. Right? Why you do it? What's the business driver behind it? Cost, sure. Speed, absolutely. What else? Scalability, recovery. Absolutely, all correct answers, right? How about for storage? How come we're not doing the same thing for storage? Because we're not, right? We're just standing up the big refrigerator array. And it doesn't work very well with virtual machines. So we want to get to the same method. So you want to do all those things, and it's about efficiency at the end of the day. That's my word, right? Efficiency. If I buy that spanking new server with 8 cores and 96 gig of memory or whatever, I want to run that thing 100% all the time because I paid for it. And the CPU does not care, I have news for you, whether it runs real instructions or no ops. It does not care. So you might as well run real instructions. Right? Keep it busy. You bought the darn thing. Well, how about your storage? Keep it busy because you bought the darn thing. Right? So you want to look at things like not only just dollars per terabyte, which is the ground beef at the grocery store method of buying storage, not advisable. Right? How about dollars per IOP? Dollars per throughput. IOPS per watt. How many watts does your storage array take? Monday I was in Oak Ridge, Tennessee. It's a wonderful town. I was at the ORNL, the Oak Ridge National Lab. This is the home of the machine called Jaguar, the world's largest, most powerful supercomputer, made by Cray Research, who I used to work for back in the day, way back in the day. Right? At scale, that machine, it has 37,000 6-core processors. When it is fully engaged, it draws 7 megawatts. 7 million watts of power when it is fully engaged. And it is a lot, right? So why did they put it in Oak Ridge? Well, they got cheap hydroelectric power. That's why they put it there. So, but even if they can save just like a measly little megawatt and a half, this is a good thing for them, right? Absolutely, because it ends up being real money. So per U per watt, this is why people use blades. They're more efficient than using standalone servers, right? So you need to look for linear scalability of performance. If I stand up the next storage blade, I want to get the same performance times 2. If I stand up the third, same performance times 3, right? This is part of the problem with legacy storage architectures. You get this nice curve that looks like this and it flattens out. You start consuming it more than 70 or 80%, now you're in trouble. Because you throw more disk at it, and you still get the same performance. You get more bytes, but not more performance. Okay. That's cloud. Now, cloud is an emerging field, as you've probably guessed. There's a lot of good work being done on it today, like the CDMI, but there's lots and lots more to come, right? There's only a handful of commercial public cloud providers. Amazon is the most well-known, but there are a bunch of others as well, right? 2 years from now, there will be hundreds to pick from. That's the good news and the bad news, right? So that's why the CDMI turns out to be really important. All right, let's talk about virtualization. Now, in casual conversation, right, if there is such a thing as a casual conversation about virtualization, right, most people think of servers. Oh yeah, I just virtualized, 30 physical servers, got them down to 2. Cool, right? That's what they mean. So a direct translation from old to new. So the old paradigm, lots and lots and lots and lots of physical servers. Hundreds, maybe thousands, right? And each, unfortunately, maybe just a single application. I've seen servers that run at 2 or 3% utilized. Just because we can, right? They're cheap. Right? Well, the human cost and the power and cooling cost turn out to be not cheap. Did you know for every dollar you put into IT infrastructure today at acquisition, how many dollars do you do operating it over its lifetime? What do you think? $1 in, how many dollars at the other end? Well, if you believe the analysts, it's anywhere from $7 to $13 you spend just operating the darn thing. Power, cooling, lighting, electricity, humans. Right? And it's getting worse. Because IT equipment is getting cheaper at acquisition, getting more expensive to run. So we have to break through this, right? So virtualization, that helps with servers. I can have few physical servers, each with very high utilization, right? Run the machine at 95% all the time. This is what mainframes do. They run all the time. So why are they virtualizing? Well, here's, this is very typical, still is in a lot of data centers. Low utilization, doesn't use too much, internal disk, right? Woe is you if you fill the disk up in that server. You know how that works. So why virtualize? Well, this is what I want to get to. Higher efficiency. I bought the 8-cylinder car, darn it, I want to use 8 cylinders, not 7 or 6 or 5. Imagine that. You go to the car dealer and, I need the V8, but you know what? You can only use 6 cylinders. Sorry. You try to use 7 or 8, the car's going to slow down. That's what legacy storage arrays do. It's no fun. All right, so that's the theory, and this is what you end up with, as it turns out, mostly because of the storage. You end up with the CPUs loafing along, and now the bottleneck is the disk. This happens all the time in virtual server. Anybody doing virtual desktop? Citrix, Microsoft, VMware View, virtual desktop. You're going to get there as well. And again, this is old idea made new. In 1988, I was using this thing called an X term, made by NCD. So yeah, he's laughing, shaking his head. That was virtual desktop, wasn't it? It was a keyboard, video, mouse on the desk, no CPU, no disk, just this blazing fast 10 megabit Ethernet connection. Blazing, right? And it worked. And this was 23 years ago, and it worked. right? Well, this is, old idea made new again, but VDI is actually very, very important. But the thing that VDI does is it squeezes the balloon. I could put 100 virtual desktops on a server. Really cool. One reason to do virtual desktop is, get this, because if I log into my virtual desktop and log off, you can set it so that desktop now goes away. It gets deleted. Gone, poof. And when I log in again, up spins another desktop, my own image. Right? Guess what I don't have to buy and run on that desktop for software? Starts with anti, ends with virus. You know how much money I save not buying antivirus licenses? You're a school district. You have 400 desktops in your computer lab at school. You are paying for 400 instances of antivirus, aren't you? And it better be darn good antiviruses, because the kids are really good at putting those in. Really good, right? If I have log-in, log-off virtual desktop, I just saved $50,000 in antivirus licenses. Because it goes away after I log off, poof, gone. It's a great thing. That's just one reason, right? So in reality, though, if you do this exercise, the CPUs today are really fast. They're wonderful. 4-core, 6-core. They're working on the 12-core CPUs. Did you know that? Both Intel and AMD are working on that. Chip about this big, 12 cores inside that. The Oak Ridge guys are salivating over those. It's like, cool. I got 37,000 times 6. Now I could have it times 12. I could do twice the science in the same footprint for the same watts. Cool, right? Problem is storage. You're squeezing the balloon. The CPUs are really fast. What do really fast CPUs want? They want data, and they got to have it really fast. Otherwise, they sit there idle and you paid for nothing. Right? So you got to have really fast storage to go along with. Okay. So here's the stages. I think my mic did my mic just check out here? All right. So I'm just going to talk loud. That'll work. We'll do it the old-fashioned way. Battery probably ran out. So who's done this drill? Right? Raise your hand. You design and test, right? You do a slow rollout into production, and then you finally get everything done, and maybe you start rolling out desktops as well. But almost everybody's doing servers first. That's the easiest nut to crack, is the servers. Let's virtualize those, get all the applications stabilized. Okay, we're cool there. Now let's attack the big fish, because you got way more desktops than you got servers. I'm just guessing. Right? School districts, public sector, hospitals. These are the 3 areas that are implementing virtual desktop right now, especially schools and hospitals. Right? Any job where workers come in on shift or approximate at the same time. Because if you're like me, and I'm guessing you are, and you sit down at your desktop machine and you either boot it up or log in, what's the first thing you do? You read email. That's exactly right. So imagine 2,500 people logging on and reading email all at the same time. What happens to your I/O workload? And you got to do that, because we're impatient people, remember? If I'm running on a virtual desktop, I want that thing to be nice and snappy, just like a real desktop. Otherwise, I get mad and I call my friends at the help desk and say, help, my machine is running really slow. You ever get one of those calls? You don't want to get that. Okay, so storage is going to be the bottleneck. If you do virtual server, but virtual desktop for sure, it's 10 times as worse. Right? And virtual servers tend to grow like rabbits, because they're so easy to make. It's like, cool, I can clone a virtual machine in 10 seconds. Let's just do that. And we'll put an application on, that'll be cool, and I'll be a hero. Well, you get a few hundred of those, and now your disk subsystem is slowing down. Because guess what? The I/Os don't go away when you virtualize. I got news for you. They don't go away. You are squeezing the balloon. Instead of running I/O through 100 interfaces, now you're running it through 2. It's the same workload. Right? So virtual server and virtual desktop, you're consolidating physical infrastructure. That's good. That's a good thing. Less equipment is better. Now, you know, this is heresy coming from a IT guy, right? But less equipment is better. I got news for you. Right? When I go into data centers today and I see, you know, thousands of little bitty individual servers, and I'm just going, oh my God, How do you remember all that stuff? I mean, I'm 35 hexadecimal. I used to be able to remember the MAC address on my PC. I can't do that anymore. I'm too old for that. So the whole idea is to make it simpler, right? But the problem is you do that, and now your virtualized environments are starved for storage performance. Again, you're squeezing the balloon. Lots and lots of fast CPUs that want lots and lots of data really fast. That's what they're built to do. And you want to keep them efficient. You know, in terms of car analogy, you got this huge, very, very powerful engine, and your transmission in the back, that can't deliver that horsepower. Doesn't work very well. Okay. Is IT a cost center? I ask you.
Should be a revenue.
Yes? Or is it a revenue center? Cool. I can make revenue from my IT operations? Can you say private cloud? Yeah, I might just be able to do that. Because if I can deliver you email and backup and DR and replication and snapshot, maybe I can deliver it to somebody else and charge them for it. And if I have an open standard to do that, CDMI, maybe I can do a standard way to do that. So especially if you work for a large company in IT, this is an interesting thing. But IT is still unbelievably considered a cost center. Right? Because not a lot of CEOs know how to, the effect of, if I put the next dollar into IT, what do I really get? Because believe it or not, us IT people are not very good at translating that equation for them. Business value. Right? Can I do 30% more transactions per unit time if you give me the next $100,000? Well, if the answer is yes, most CEOs would go for that. But if you can't answer the question because you haven't studied your own infrastructure, they're not going to give you the money. That's the way that works. And I just love it, the airline magazine, right? CFOs and mayors, remember I did this for a public sector group, right? They read the new cool widget in the airline magazine. It's like, oh, cool, I got the iPad Model 22. That'll be cool, we'll buy one of those for everybody. Okay, Joe's the IT guy, go implement that. It's not quite that easy, right? So they expect IT to do magic tricks. Some of them still do. IT is not magic, guys, not magic. So density and efficiency. Again, for my money, I'm paying the power bill. I'm paying the cooling bill, which is even worse, right? Density and efficiency are paramount. They're paramount, right? How many of you still drive a carbureted car? I don't see any hands go up. Did you know that fuel injection was originally developed, Robert Bosch, in the 50s? In the 50s. And it took almost 30 years to get fuel injection into production cars. It's much more efficient, right? Why are we running carbureted storage arrays? Because we are. Be more efficient with your dollar. If I'm going to give you $1 for storage or for compute or for networking, doggone it, I want that thing to be as efficient as possible. I don't want to run it at 20%, I want to run it at 95%. And if I can't, I'm going to go somewhere else so I can get the 95%. That's the whole idea. Less power and cooling per rack. Again, the guys down at Oak Ridge are the far, far right edge of the spectrum. They worry about that all the time. All the time, because they're into the megawatt range. Now, hopefully you all aren't running 20 megawatt data centers, or at least I hope not. But 20 kilowatts, oh yeah. People are designing now racks to consume 20 kilowatts per rack with blade servers, right? And if you can reduce that by a little bit, what do you pay for a kilowatt hour here? 9 cents? Yeah, in St. Louis I pay 7.5, which is not bad. Around the country, New Jersey, 14. You do not want to build a data center in New Jersey, right? Or at least a big one, right? So why is Google building data centers in, of all places, western Iowa? Cheap electricity. Give the man a prize. 2 cents a kilowatt hour. 2 cents. They're building massive data centers there. Who knew? Just outside of Omaha. Right? So data ingestion is still growing exponentially. Have you ever sat down and studied how data comes into your company? That's an interesting exercise. Email? Sure. Public websites? Getting information from those? Of course, sure. Right? How about employees walking in with a USB stick? Think that happens? You bet it does. All the time. right? And people wonder why their data grows, and not just linear, it grows exponentially, right? Never mind the applications that generate more and more, because more data is typically a good thing. I can do more analytics, right? But replicating it, backing it up, I've been in this business, again, 33 years, and people are still complaining about backup. And my answer is, why are you doing backup? How about replicating instead of backing up? That's interesting, right? Backup changes the form of the data. Replication does not, right? This is why all the major cloud providers don't back up your data. They replicate it, and they replicate it to different geographies. That's what they do. None of these cloud guys do any backup at all. VDI, we talked about that. And here's, part of the target, right? You're moving to virtualized server desktop infrastructure, but how do you deal with the data, the storage, right? Because it will bottleneck your storage. If you try to put up 200 VDIs, for example, on just a few disks, you're going to get bottlenecks for sure. I counted Windows 7. Who runs Windows 7 here? Now, on their desktop. Yeah, so I run it virtual on my Mac. It's great, right? And I run the normal kind of antivirus and Adobe and, the other services stuff, right? Guess how many IOs during boot? Take a guess. How many IOs happen to this disk when I boot Windows 7? I counted. Answer, 1,100,000 per desktop. Do you see the problem? Yeah. I got 400 nurses coming in at 7 a.m. and they hit the key and it boots. 400 times 1.1 million IOs occur, and they all want them to go like that because we're impatient. Right? So you got to have not only just highly reliable, but very high performance storage to go with that. Right? This is kind of what it looks like. Again, we'll kind of end with a diagram. So I have storage blades, again, blade servers, small one-use servers. I've got them virtualized, making sure that I've got storage blades to go with them, because as I scale virtual servers, I can scale storage. Right? You buy the big refrigerator array, that works for a while, and then the next step is another refrigerator. That costs a little money. Plus, it's hard to maintain. Plus, it's not a 5-year warranty piece of equipment. Right? BMW is in South Carolina, right? Yes. I just bought a BMW, 2 years old, BMW 328i. I am in love with that car. It's a wonderful, wonderful car. It's very efficient. I drove it from St. Louis to here, 33 miles a gallon. V6, 33 miles a gallon. I'm kind of proud of that. Right? My company's kind of proud of that because they're reimbursing me. So they're happy too. Right? But the whole thing is it's much more efficient. Right? Much more efficient. Plus, it has a great warranty. These cars now have unbelievable warranties. You buy them new, it's 10 years, 5 years. It's wonderful. The storage array should be the same way. That's why we do a 5-year warranty for $0. Zero is an interesting business proposition. It scales really well. They taught us that in 2nd grade, right? 0 times any other number, 0. That's a great thing. So I want to be able to scale because, again, as I virtualize servers, I went one too far. And I'm almost done anyway. Phil's going to give me the hook here. So as you virtualize servers, you need to be able to scale with that in storage. And whether you're doing private cloud, which we talked about, really good idea if you can get an SLA with teeth. Right? Or you're doing virtualization within your own IT infrastructure, either servers or desktops. It turns out that the bottleneck is storage. Storage is the last frontier. It's where your data goes. It's data at rest, isn't it? Right? Because you got lots and lots of data. And those CPUs want that data. So having efficient storage turns out to be the answer in virtualized environments. All right. Do I have time for a question, Phil? Solamente uno?
Just take one question.
All right.
Make it a good one.
Make it a good one. Are there prizes involved?
Not for the question.
Oh, darn it. Yes, sir.
In continuous improvement, storage is defined as a waste. So when you store all this information, what percentage is value added?
What percentage is value added? I will give you the classic engineering answer. It depends. Right? Now, as a storage guy, I have to tell you, data classification turns out to be really, really important. Because if you store something, a file, say, and you store it once, and it lives forever, and nobody reads it again, what have you done? It's total waste. Not just temporal waste, but permanent waste. That's exactly right. So now people think, well, I'll compress it or dedupe it or somehow squish it down to just its essential bits, and then we'll be done with it. But then you got to back it up and replicate it and protect it and secure it. That's it. So my answer is don't store it in the first place. This is why data ingestion into your company is really important. You have to know what's coming in. You may want to set business policy that says, oh, Rob's bringing in any MP3s on a stick? Not going on our servers. Can't store it. You can read it, you can't store it. Right? So knowing what to store and how it's stored becomes critical. This is why you talk to the records manager people. You might have several hundred types of records in your business. An invoice, a purchase order, right? An inventory request. These are all records. And those have to be stored and protected. You might be under HIPAA or SOX or GLB or whatever regulation there is. But that's known. And then there's this mountain of unstructured data. Right? I send you an email with attach it. You send it to 12 of your buddies in the corporation. Now I got 13 copies of the same doggone thing. Well, my answer is let's be a little more proactive. Store it once and then share that out. Right? Repositories for information, not individual copies. Plus, it saves you money, too. So that's really where it's at. But you're right. I see storage arrays all the time that are consumed with data. About 20% of it is useful. And you can tell what's useful data by what gets read by the applications in the line of business. What gets read. Right? What isn't getting read, that might be a red flag, no pun intended.
Ladies and gentlemen, a round of applause for Rob Peglar.
Thank you.